In this video, we'll be explaining why the traditional addition algorithm makes sense. Let's start by adding two three-digit numbers, 468 and 573. The first thing that we do is we make sure that our place values are aligned. So we align by place value the ones together, the tens and the hundreds. Then I'm going to talk through this. I'm assuming that we're all adults proficient with the traditional algorithm. We'll step back after we're done and see why it makes sense. So we start in the ones place. 8 plus 3 is 11. Write down the 1, carry the 1. Then in the tens place, 7 plus 6 plus 1 is 14. Carry the 1. 5 plus 4 plus 1 is 10, so our answer is 1041. To start with, let's see what we did. We aligned by place value, and the reason why this makes sense is because we want to align to combine like-valued parts. When I added 7 plus 6 plus 1, it didn't really matter that I was in the tens place. It mattered how many tens I had. So I'm just counting how many parts I have here. Because I've aligned by place value, they're like-valued parts. Let's look at the carrying. Let's go into our video here. So our 11 is actually one group of 10 that we group together. Here with our manipulatives, we form the rod. So once we form the group of 10, it needs to be promoted into the tens place so we can be grouping like-valued parts. I record that one unit down here alone. Then in the tens place, when I add them together, I get 14. But important here is that a group of 10 tens can be combined to 100. So 10 tens, 10 rods, we form a flat, and we put it in the hundreds place because now we need to have like-valued parts here. I record my 4 tens down here with my answer. Then in my hundreds place, I have like-valued parts, so I can just add up how many I have. It turns out here that I have 10 hundreds, so I can stack all of these flats together to form a cube. So once I have 10 hundreds, that makes 1,000, and so I promote it to the thousands place, and I end up with 1,000 here, and I don't have any in the hundreds place. So again, aligning by like-valued parts allows us to just count how many of each of those parts we have, and whenever we form a set of 10, we group it together and we would promote it to the next place so we can again be adding like-valued parts. Let's summarize this. Procedurally, we start by aligning numbers by place value. This is the what we're doing. Then when we look at the conceptual, this is the why we're doing what we're doing. Why do we align numbers by place value? This is so we can add like-valued parts. Procedurally, we carry the 1 when the sum of a column is a two-digit number. Conceptually, we group sets of 10, and then we promote that new set to the next place value, so it's with like-valued parts, and we can combine them. This algorithm works for numbers in other bases as well. Here we'll add two numbers in base 5 with the help of some base 5 manipulatives. When you're learning something new, the manipulatives can be very helpful for understanding what's going on, especially this business with our carry the 1, with our regrouping. So here we have our ones place. We can combine 5 ones together because in base 5 we look at groups of 5. So we'll replace those 5 ones with a rod. In our algorithm over here, this was the carry the 1, and we had 1 unit down here at the bottom. The 1 was one group of 5 by 1. Then when I come over here to my rods, I can combine 5 rods together. 5 sets of 5 by 1 is going to give me 1 flat, or 1 5 by 5. I'm left with 2 of the rods, 2 of the 5 by 1s. I record those, and my carry the 1 was 1 5 by 5. And then now I have 1, 2, 3, 4 of these flats. And so my answer here, 4, 2, 1 in base 5.